All right, everyone, what's good with it? What's up? This is nuclear decay worksheet. Yeah, let's get into it. The reason why a lot of it's actually re-recording. I said something wrong in the first one, so I'm re-recording it. Yeah, there's just the intro part. So yeah, let's get into it. Mind you, I do speak a little bit slow, and oftentimes I'm like having weird pauses in between. That's because I'm not trying to fact check my stuff. Yeah, so please feel free to speed up the video to your liking. But yeah, let's get into it. So number one is to write the isotope topic symbols for alpha. So alpha, right, as in here. So alpha radiation is it emits helium nuclei, which is also called alpha particles, and this is what it looks like. And so for this first section right here, we just have to write the symbols. Helium is being ejected, or helium. Oops. Yeah, alpha particles that contain two protons and two neutrons and has a positive charge. Um, I think this is going to be hold up. Mm, where is it? Where is it? Where is it? Oh, hold up. All right, my bad. So yeah, I just want to explain like what these numbers mean. So the top number, the 4, is a mass number. Bottom number is atomic number. The atomic number is just the number of protons. This is just number of protons. Yeah, so the atomic number is what we look at to identify like what's the number for like finding it on the periodic table, right? We look at periodic table. Oh, I don't actually have one here, but yeah. So the bottom number is to find the protons. The number on top is the mass number, which is essentially like the number of protons plus neutrons. So top number is protons plus neutrons. The bottom number is just the protons. All right, so let's get into it. Um, beta decay. Beta decay is down here. Where is it? Right here. Oops. Beta radiation. It's an electron resulting from a breaking apart of a neutron in an atom called beta particle. The neutron breaks apart into a proton, which remains in the nucleus. A fast-moving electron is released. So beta radiation happens when we're turning neutrons into protons. All right, we start from neutrons, we turn into protons. And when we do that, beta a beta particle is released called beta decay. So we just write the symbol E 0 -1. All right, gamma. Gamma is a photon, right? A photon, oops. It's a photon, it's a high energy photon emitted by a radioisotope called a gamma ray. So gamma rays, they have no mass and no charge. Uh, Um, right, so it's gonna be that's a symbol, no mass, no charge. Oh yeah, I forgot to explain for the beta one, right? The mass number is is 0 because mass number is proton plus neutrons, but this is electron, so that's not in there. It's 0. And the atomic number is number of protons, and we have -1 protons. And since protons are positive and electrons are negative, we just have -1 protons is like 1 electron. So, right, gamma, back to gamma. The emission of gamma radiation does not alter the atomic number, does not alter the atomic number or mass number of an atom. Okay. Next up is positron. The positron is the same thing as a beta radiation, but it's uh but it's positive as a positive charge. And so it has a mass of an electron, but a positive charge. Um, And so for this one, what happens is that a proton changes to a neutron. Proton changes to a neutron, and it uh, releases a positron. Um, so yeah, releases a positron 0 + 1, right? Mass of an electron, right? It's over here, but it's a positive charge. All right, next one is neutron. Neutron was back up here in beta decay, I believe. Yep, right here. So neutrons is right here. That's a symbol. We can just write it here. And 1, 0. The reason why it's 1 is because that's the mass number, right? Mass number is the protons plus neutrons. In this case, neutron, right? This is literally a neutron. I mean, there's one neutron. That's one right there. And 0 is down here because atomic number only represents the amount of protons. In this case, a neutron, right? It only has, it's a neutron. No protons, no electrons. Our nuclear change for beta decay. Uh, Beta decay happens when there's too many neutrons. So when there's too many neutrons, it goes to neutron or proton. All right, positron decay. This one happens when there's too few protons or too few neutrons. So that means you need to get more neutrons. So it turns from proton to neutron. All right. Complete these nuclear charges. All right, so the first thing I like to do is to look at these numbers and to see what's missing. All right, so for the first one, it's 238 goes into 234. So 234 plus 1 equals 238, and that'll be 4. 90, 92, 92 to 90. 90 plus 1 equals 92. That will be 2. And then this isotope particle will be helium. You right. Um uh the second one, oops. This will be called alpha particle, alpha decay. All right, the next one. It's 234, 234, 234, right? Nothing's being changed here. But for the bottom number, it goes from 90 to 91. And so 91 plus what equals 90? And this will be -1. And so the only sign that is -1 is beta decay. E. All right, alpha decay. This is alpha decay. Now we need to find out the element. Um, so let me pull up a periodic table. There we go. All right. So 234 breaks down into 4 and something else. So that means like what plus 4 equals 234, and that'll be 230. And then 291 right here. So what plus 2 equals 91? That'll be 89. And the way you want to find out the element in the periodic table is to look at the bottom number. So 89. So you need to find something that's 89. Over here, so it's AC. Okay, sweet. Number 4. 220 breaks down into 4. So what plus 4 equals 220? So it'll be 216. And then what plus 2 equals 86? So 84. So when you find an element that has something that's 84, and this will be polonium. PO. All right, sweet. Halfway through. All right, so 216 goes down to 0. So what plus 0 equals 216? That'll just be 216. 84 breaks down to -1. So what plus -1 equals 84? 85. Right, because 85 minus 1 equals 84. Sweet. All right, now we need to find something that has 85. That would be AT, that's that time. Acetine, I don't know. All right. Um, Next one is 6. Carbon breaks down to nitrogen. So 14 to 14. So what plus 14 gets 14, that'll be 0. Um, and then 6 breaks down to 7. So 7 plus what equals 6? -1. Because 7 minus 1 equals 6. And so as you see here, this will be a beta decay. So you're gonna write E right here, and then a beta decay. Beta decay. All right, next one. BI breaks down into what's this here? Beta decay. So one of them is going to be E 0 minus 1. All right, and then 210 breaks down to 0. So what plus 0 equals 210? This will be 210. And then 83 breaks down to -1. So what plus -1? Or what minus 1 equals 81, 83, 83? I'll just be 84. So let's find something that's 84. All right, let's fill up PO, polonium. Sweet. Oops. All right, next one. This one says it's going to be neutron bombardment with alpha emission. So this how we do this one is we add everything on the reactant side. So this will be 11 on the top, and then this one will be 4. So what plus 4 equals 11? There's 7. For the bottom numbers, this will be 5. This one will just be 2. So what plus 2 equals 5? This will be 3. So something that has an atomic number of 3 will be lithium. Our next one, number 9. This is a positron decay with gamma emission. So positron is ejected. Positron decay is so positron is ejected, so +1. All right, so now let's do the same thing we did earlier. So this side's 23. This side is 0 still, because 0 plus 0 is 0. All right, so the top number will be 23. The bottom number will be 12. This one will just be 1. So what plus 1 equals 12? 11. The atomic number of 11 is Na, sodium. Oops. All right, sweet. That's your nuclear decay worksheet. All right, thank you guys for watching. Later.